Hi, this is Codeforces question quiz master. A school has to decide on its team for an international quiz. There are n students in the school. We can describe the students using an array A, where AI is the smartness of the ith student. There are m topics 1, 2, 3, m, from which the quiz questions will be formed. The ith student is considered proficient in topic T if AI mod T equals 0. Otherwise, he is a rookie in that topic. We say that a team of students is collectively proficient in all the topics if for every topic there is a member of the team proficient in this topic. Find a team that is collectively proficient in all the topics such that the maximum difference between the smartness of any two students in that team is minimized. Output this difference. For this example, we have n equal 5, and that means we have 5 students. Student number 1, number 2, number 3, number 4, and this is number 5. And m equal 7, and that means we have 7 topics from 1 to 7. 1, 2, 3, 4, 5, 6, and 7. And we need to find a collection of students such that they cover all the topics. For example, if we take student 6, 6 mod L1 equals 0, and that means student 6 can cover topic 1. 6 mod 2 is 0, so student 6 can cover topic 2. 6 mod 3 also 0. 6 mod 4 is not 0. 6 mod 5 is not 0. That means student 6 cannot cover these topics. 6 mod 6 is 0. 6 mod 7 is not 0. So student 6 covers topics 1, 2, 3, and 6. Let's take the second student, which has the value 4. Now 4 mod 1 is 0, but 1 is already covered by the first student, and 4 mod 2 is 0, but 2 is covered from student 6. 4 mod 3 is not 0, but we don't need to check it. 4 mod 4 is 0, so we cover this topic. 4 mod 5 is not 0. 4 mod 6 not 0. 4 mod 7 is not 0. Let's take this student and let's check for the uncovered topics. 3 mod 5 is not 0. 3 mod 7 is not 0. So student 3 only covered topics 1 and 3 that are already covered. Let's check for student 5. 5 mod 5 is 0. 5 mod 7 is not 0. Let's check student 7. 7 mod 7 is 0, and that means taking the collection of the students 6, 4, and 3, 5, and 7, which is all the students. Those students cover all the topics, and the difference between the smartness of any two students in the team is minimized, or the maximum difference, and the maximum difference is the maximum value, which is 7, minus the minimum value, and this equal to 4. So having this collection of students, the difference will be 4. Now let's see if we can get a better solution better solution means the maximum difference is minimized or better than 4. Now if we take student 7 can cover topic 7 and 1. If we take student 5 can cover topic 5 and 1, but 1 is already covered. Now if we take student 6 can cover topic 6, 3 and 2, 1 is already covered. Now if we take student 4 can cover the remaining topic 4, and so having the team of students 4, 5 and 6 and 7, we managed to, or this team can cover all the topic, and the difference between the maximum and the minimum is 7 minus 4, which equals 3, and 3 is less than 4. So this will be our answer for this example, as this is the maximum difference between any two pairs of collection of students that can cover all topics. Now how can we solve this question? First of all, we need to calculate for every number only one time. We need to know what are the dividers or divisors for any number between 1 or 0 to 1 to the power 5, and that's because n we have is 1 to or 10 to the power 5, and we, for every number, we loop from I to the square root of the number and check if the number is, or number model I equals 0. In that case we push it to our vector. Also at the same time we push num divided by I, and that's because if we have, for example, 6 model 2 equal 0, so we push 2, so 2 is the divisor for 6, and also 6 divided by 2, which equal 3 also is a divisor for 6. The same 6 model 1 is 0, so 1 is divisor. Also 6 divided by 1, which equals 6, and 6 is divisor. So we push I and num divided by I, and the time complexity for this calculation is 10 to the power 5 multiplied by square root of 10 to the power 5, and we calculate this only one, and we pass it to every test case later on. So now we have the divisor for every number. Now to solve this problem, first of all we need to sort the array based on student value. So after sorting this array, we'll have student 3, then 4, then 5, then 6, then 7. Now we need to use sliding window to find for every index what is the minimum sliding window to cover all the topics, and we start with the first student, and to do that we need a dictionary count that will count the topics covered so far by the students. So we start with student 3, and we loop over all the divisors for student 3, let's first put the divisor's value for all the students. So for student 3 we have divisors 1 and 3. For 4 we have 1, 2 and 4. For 5 we have 1 and 5, since 5 model 1 is 0 and 5 model 5 is 0. 6 we have 1, 2, 3 and 6. For 7 we have 1 and 7. Now count dictionary is initially empty, and we start with student 3. We loop over all the divisors from 1 up to the max value m, because we need only to cover m topics. So 3 mod, so 1, so first divisor is 1. Notice that also for every number we sorted the divisor incrementally, so that if the divisor is greater than m, we skip it or we break. So here we have 1, 2, 3, 6, 1, 7, 1, 5, 1, 2, 4, 1, 3. Everything is sorted. Now here we have 1. Let's see which topics are covered. So 1, here we have 1 and the count is 1. Then before adding 1 to 1, we know that the count of 1 is 0, because the count dictionary is initially empty, and that means because it's 0, that means we covered one of the topics. So we have this window count variable, which is initially 0. So window count equal 0 initially. Now this value 0, and so we increase the window count by 1, and 1 will become 1. Then we have 3 initially 0, because there is no 3 covered already, and that means that we covered a new topic. So 1 plus 1 is 2, and the number of 3's so far is 1. Now this is the end of the divisor for 3. Now we need to check for the next student 4. We need again to loop over all the divisors up to the value m. So 1, if the value for 1 in the count is 1, it's not 0, and that means the topic 1 is already covered. No need to increase the window, but we need to increase the number of ones covered so far. So 1 plus 1 is 2. Then we have the value 2. Now 2, the number of 2's in the count is by default 0, and that means we are going to cover a new topic, which is 2, and we increase this window count to 3. Then we have divisor 4, and the number of before 4 we have to increase the count for 2 by 1. So we have until now 1, 2. Then we have 4, for initial value in the count is 0, so we increase the window count 4 and this becomes 1. We are done with this students. Then we move to the next student 5. 5 we have this divisor 1. For 1 we have 2, the value 2, so that means the topic 1 is already covered by the previous students, and no need to increase the window count. We will only increase the number of ones by 1, which is 3, and this means there are 3 divisors or 3 students that have divisor 1, and that's true because 5 model 1 is 0, 4 model 1 is 0, and 3 model 1 is 0. Then we have 5 is not in the count, so it's the value is 0. Then we increase this by 1, become 5, and the number of 5 is 1. We are done with this student. Then we have student 6. Student 6, we have the value 1 is already not 0, so we just increase this by 1. We don't increase the window count. 2, we have 1 value, so we just increase this by 1. 3, we have 3, so increase this by 1. 6 is not in the count, so increase the window by 1, so it becomes 6, and we add 6 to the dictionary. So until now we have 6 topics covered, and that's not enough. We need all the topics to be covered. Then we move to the next student 7. The first divisor is 1, so we just increase this to 5. Then 7 is not here, so we increase this by 1, 7, and we have 1 7, and that means for student the first student we need this whole window to cover all the topics, and this is what we did here in this loop. So we loop over the element until n, while I less than n, and whenever we reach window count equal m, we break the loop. So if only 3 students can cover all these topics, this will be our window, but in this case we needed all the students. So we break here and we check if the window count less than m, because it's possible that the window count or all students does not cover all topics. In this case we return -1, and initially the answer will be array of index, which is 7, our index here. So this is index, and this is the end of the window. So the value here of 7 minus array of 0, which is 3, so we store in the answer equal 4. And now we need to slide this window for next students, and this is what we will do in this loop. So we move to student 1, and because we move to this student, so the sliding window should start from here, and we need to update our count dictionary, because we removed student 3 from the window, and this is what we do in this loop. We will loop over all the divisor of I minus 1. This is I minus 1, and while doing that we will decrement the counter. So we are for student 3 we have first one divisor, and we have for 1 we have 5 values, so we decrease it by 1 and it become 4, and whenever it reaches 0, that means one of the topics is no longer covered, but in this case it's 4, so still topic 1 is covered by other students, or by 4 other students. Now the next value is 3. Here we have 2, so we subtract 1, so it become 1. 2 minus 1 is 1, and we are done for all divisors for this students. And as you can see here, the value for window count is still 7, and that means for this student, this is the window that cover all the topics, and the difference between the maximum, the index, we did not move this index, still at this, the last element, the difference between the last and the current one, 4, which is 7 minus 4 is a 3, and this is less than the answer, so we update the answer to 3. Then we move to the next student 5 have divisor 1, so this becomes 3, and then we have this 5, so 5 becomes 0. 1 minus 1 is 0, and this means topic 5 is not covered. And what we need to do, so we have 6, the window count is 6, so we need to look at the end of the window if we can find more students that can cover this topic 5, because the count of 5 is 0. So let's say here we have 15, so after we move here 15 can cover 5, and so we increase our window. And this is what we do in this loop. But in our case, this is the end of the array, and that means because index plus 1 is equal to n, this is the end of the array. So here we break, and the window count will be 6, which is less than 7. So we could not, for 5, we could not find a window that cover all the topics, and so no need to continue, because we reached the end of the array, and so moving this direction will only decrease this window count, and that means that this will be our final answer. And remember, while moving from students to another students, we just did 7, or the value at the index minus the value at I, and this is the answer, or we check it if it's better answer. and that's because 7 minus 4, because the array is sorted. This is why we can do this, because we know the last element at the window minus the first element at the window give us the value or the maximum value. One more note is, what if we have students like 1, 1, 3, 3, and 5? One optimizer for optimization for the solution is to remove the duplicates. So here we have 1, 1, so we can remove this one and remove this 3 and take only the unique value, and that's because all the topics covered by this student could be covered by this one, so no need to just repeat the students with the same values. And this is what we done at the beginning here using the unique function. It will sort the array such that it will take only, not sort, it just will take the unique elements of the array, so 1, 3, 5, and the other elements will put it at the end, and this will be the end of the array. So this, it will return this, it will iterate to the end of the unique elements. So this is our new end, the size of the unique elements array. In this case it's 3.